All right, let's jump right in. Today, we're going to tackle a super important networking skill, IP subnetting. I know, it sounds kind of technical, but trust me, it's all about bringing order to chaos. Think of it as taking a huge, messy digital crowd and sorting it into clean, organized, and super efficient neighborhoods. So, picture this. You've got hundreds of devices, servers, laptops, phones, you name it, all thrown together on one single flat network. What happens? Well, every time just one device sends out a broadcast message, it's like it's shouting, and every single other device has to stop what it's doing to listen. That constant chatter just grinds your applications to a halt. And even worse, a security problem on one machine can spread like wildfire to everything else. It's a total nightmare. And that is the exact problem subnetting is here to fix. So, to really get a handle on this, we're going to build it up step by step. First, we'll look at the IP address itself. Then, we'll cover the tools we use to divide it all up. After that, we'll walk through a real example, get into why this is so darn important, and finally, see how it all clicks together in the real world. Sound good? Okay, let's get started. First things first, we've got to talk about the foundation of all of this, the digital address. I mean, before we can even think about slicing up a network, we need to understand its most basic building block, right? So, what is an IPv4 address? Well, underneath it all, it's just a 32-bit number. But since looking at 32 ones and zeros is a headache, we break it down into 4 numbers, separated by dots. We call these octets, and they're just there to make it easy for us humans to read. Each of those octets is made of 8 bits, and that's exactly why each number can only be between 0 and 255. Now, here's a key concept. Every single IP address is split into 2 parts. Think of it like a home address. The first part, the network portion, that's like your street name. It tells everyone which neighborhood or which network a device is on. The second part, the host portion, that's the house number. It points to one specific, unique device on that street. Okay, so that's a great analogy, but how does a computer know where the street name ends and the house number begins, right? Well, that's where CIDR and subnet masks come into play. You can think of them as the blueprint for our entire network. Now, CIDR, that stands for Classless Interdomain Routing. But don't worry about the long name. It's really just a super handy shorthand. The most important thing to look at is that number after the slash. If you see /24, it's just telling you, hey, the first 24 bits of this address are the network part, which leaves the last 8 bits for all the individual devices or hosts. And this table here shows you the core trade-off perfectly. Just look at the pattern. As that CIDR number on the left gets bigger, going from /24 to /25 to /26, the number of bits left for hosts gets smaller. So with a /24, you've got 8 host bits, which gives you 256 possible IPs. But if you borrow some of those bits and move to a /26, you're left with only 6 host bits, and that means you only get 64 IPs per network. It's always a balance. All right, so we've got the blueprint. Now it's time to get our hands dirty and actually start building. Let's see how this whole subnetting thing works in practice by taking a big block of addresses and slicing it up into smaller, much more useful chunks. This pizza analogy is honestly the best way to think about it. It just clicks. Imagine you start with one giant pizza that has 256 slices. That's your whole network. When you subnet, you're not throwing any slices away. You're just cutting that big pizza into, say, 4 smaller, personal-sized pizzas. You still have 256 slices in total. They're just organized into smaller, more manageable groups. So let's walk through exactly how this works. Say we start with a standard /24 network, which we know gives us 256 addresses. And our goal is to create 4 separate subnets. Okay, how do we get 4 from, well, math? We need to borrow 2 bits from the host part of the address. Why 2? Because 2 to the power of 2 is 4. That gives us our 4 subnets. So we just add those 2 borrowed bits to our original 24 network bits, and boom, our /24 becomes a /26. And here is the beautiful result of that little bit of math. Our original big block of 256 addresses is now neatly divided into 4 smaller, much more manageable /26 networks. You can see each one gets its own slice of the pie. The first one gets addresses 0 to 63, the next gets 64 to 127, and so on. We've literally created order from chaos. Okay, so we've covered the what and the how. But maybe the most important question of all is, why? Why do we go through all this trouble? Understanding the real-world benefits is where you'll see the true power of subnetting. This really gets to the heart of it. Let's look at the before and after.
Before subnetting, you've got a total mess. The network is clogged with all that broadcast chatter, there are zero security boundaries inside, and just trying to organize it is a nightmare. But after subnetting, you solve all of that. You shrink the broadcast domains, which quiets everything down. You can now put firewalls between your subnets to control traffic, and you can finally organize things logically, like putting the whole engineering team on one subnet and the marketing team on another. I love this shouting in a room analogy because it's so accurate. On a flat network, even a simple everyday request is a broadcast. It's a shout that every single device on the network has to stop and listen to. It's incredibly inefficient. When you create subnets, you're essentially building walls and creating smaller rooms. Now, those shouts, those broadcasts, stay contained within their own room. This cuts down on the noise like you wouldn't believe and makes the whole network faster for everybody. All right, for our last section, let's zoom out a bit. Subnetting doesn't exist in a vacuum, so let's see how it fits into the broader ecosystem and works with a few other really important networking concepts.
Okay, this is a big one. People get confused about VLANs versus subnets all the time. The easiest way to think about it is that they're best friends who work together. A VLAN is a layer 2 thing. It happens at the switch level. It's like drawing virtual lines to group devices together. Then the subnet comes in at layer 3, the routing level, and gives that group its own unique IP address and neighborhood. Most of the time, you'll see one VLAN for every one subnet. They go hand in hand.
It's also super important to know that not all IP addresses are created equal. The addresses you use inside your company, for your laptop, your printers, your internal servers, those are private IPs. You'll see them in those common ranges like 192.168. They are not allowed on the public internet. For anything to be reachable from the outside world, like your company's website, it needs a public IP address. That's a globally unique address that you get from your internet provider. So that begs the question, right? How does your laptop with its private IP actually get out to the internet? The magic happens with something called NAT, or Network Address Translation. The best way to picture it is like a receptionist at a big office. Your router acts as that receptionist. It takes the requests from your laptop, swaps out your private internal IP for its one public IP, and sends the request out. When the answer comes back from the internet, the router remembers who asked and forwards it directly back to your laptop. It's the bridge between your private world and the public internet. All right, let's do a quick recap of the most important things to remember. Number 1, subnetting is all about organization, not creating new IPs. 2, it's always a trade-off. The more subnets you make, the fewer devices you can have in each one. 3, a huge reason we do this is to cut down on that broadcast noise and make things faster. 4, VLANs are layer 2, subnets are layer 3. They're best buds. And finally, we use private IPs internally, and NAT is the magic that lets them talk to the outside world. And that really brings us to the whole point of all this, the real power. So I want to leave you with a question to chew on, a way to apply what we just went over. Now that you know how to build these separate, structured networks, imagine you've created one for your engineering team and another for your marketing team. What is the very first security rule you would create between them? Think about it. What kind of traffic would you absolutely want to block, and what might you need to allow?